Section 2.3 is a star section. We want to find a derivative. A derivative is instantaneous rate of change. That is the slope of a tangent line. What a tangent line is a line that touches the curve at one point, let's say A. Actually, let's leave it general. Let's say at some point X. So I need to find the slope of that line, and of course this is y equal f of x. So this point right here is x f of x. The issue with that, to find a slope of a line, I need 2 points. So somebody came with the idea of, well, you know what? Take x and add a delta x to that. That makes this point x plus delta x. And the y associated with that, x plus delta x, f of x plus delta x. And they said, well, why don't you find the slope of this line? So the slope of this line would be y2 minus y1 over x2 minus x1. y2 is f of x plus delta x minus y1 is f of x over x2, which is x plus delta x minus x. The x's cancel out, so I'm getting the slope of the secant, as secant means a graph that crosses a curve at 2 points. But if I find the slope of this line, that's really the slope of the green line. You'll say, wait a minute, the slope of this line is not the same as this line. And somebody came up with the idea of, okay, instead of delta x, take half of delta x. Instead of adding delta x, add half of delta x. Find the slope of this secant line. And can you see what just happened? The slope of that line will still be this, because you're going to call this delta x, right? So the brown line is closer to the red line than the green line was. And if I were to go ahead and cut that again in half, let me pick, let's say this guy. If I cut it in half, if I find the slope of this line, I know it's a bit hard to see this color, but do you see that the slope of this line is very close to the red? Now, I had an x, let me use it back. I had an x, I added some delta x, then I cut delta x in half, then I cut delta x in half. Do you see that I'm trying to shrink this back to x? Well, if delta x was a value, then I cut it in half, the second stage. Then I cut this in half. Do you see that if this is 10, this is 5, this is 2.5? So what I'm doing, I'm shrinking delta x to 0. If delta x approaches 0, then I get the two lines infinitely close. And therefore, that would be a very good approximation of x itself, the tangent line. So this is the slope of the secant line. If I want the slope of the tangent line, all what I have to do is take the limit as delta x approaches 0 of this, and that should be the slope of the tangent line. So slope of the tangent line. So the way it works, this is the definition. This is what's known as a derivative. Derivative is the limit as delta x approaches 0 of f of x plus delta x minus f of x. And the notation Derivative is what we call it in calculus, but different fields have different names. Normally we call it f prime. It could be y prime. dy dx, that's the same thing. d dx of f, that's the same thing. In differential equations they use these notations. This is the most used. Another name for a derivative in physics, they call it velocity. And we have a main use for it. We call it the slope of the tangent line. And what that is a line crossing a curve at one point. This is also called instantaneous velocity. So slope of a tangent line is a derivative. And what a derivative is, taking f of x plus delta x minus f of x divided by delta x, which is called the difference quotient, and taking the limit as delta x approaches 0. Now, there are no examples in this section. The only examples where we use this definition is in section 2.4, and 2.4 is not required to cover, not for your class. So the idea is, if I find the slope of a tangent line that's instantaneous rate of change, or simply its velocity. And I do want to point out a normal line is perpendicular to a tangent line. That indicates the slope of the normal is -1 over the slope of a tangent, the reciprocal. And let me just demonstrate really quick how this works and why are those useful. If I have a curve y equal f of x, if I find the tangents tell me how is the curve behaving at these points. That's very useful to know. So the red would be the slope of the tangent. The slope of the normal line is perpendicular. That's also very useful. That gives me a very good idea of what the function is doing at all of these different times. So the only definition in the book that talks about a normal line, it simply says this: a normal line is perpendicular to a tangent line, which means once you find the derivative, which is the slope of the tangent, the slope of the normal line is the negative reciprocal. We're going to do a couple of examples in 2.5, and then I have 4 examples to work out. Example 1, let's apply this derivative, and there it is. If they say find the velocity, find the slope of the tangent, they're saying the same thing. You're going to say y prime, or f prime, is the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. That is the limit as delta x approaches 0. F of x plus delta x, replace x plus delta x wherever you see an x. There it is. Plus 2. That is this piece. Minus f of x is simply what you see. Now do you notice here, if you let x equal 0, you'll get f of x minus f of x, which is 0, and delta x approaches 0, that's a 0. So what does that mean? You need to manipulate every time. The key, this delta x must cancel out, because that's the only 0 in the denominator. So all what you have to do is apply what you know from algebra, distribute the negative n, And you'll notice those two cancel out and those two cancel out. And once those delta x's cancel out, wouldn't that simply be, and from what we learned, if you plug 0, you get 3. That is the slope of the tangent line. If I look at a quadratic and I want to find the derivative, I want to find the slope of the tangent, I want to find the velocity, the rate of change, instantaneous rate of change, that is the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. Now, calculus uses h instead of delta x, so you might have seen it that way. And again, no big secret, I'm going to get 0 over 0 every time. What is f of x plus delta x? So wherever you see an x, replace it by x plus delta x. That's x plus delta x minus x plus delta x squared. That's the first piece, minus f of x. F of x is exactly what you see every time. Make sure to use parentheses. And again, at any given stage, I let delta x equal 0, I get 0 over 0, which means I didn't manipulate it. Well, obviously, the only variable in the denominator is delta x. That has to cancel out, and that cancels out algebraically. If you FOIL this, that's x squared plus 2x delta x plus delta x squared. Distribute the negative end, minus x plus x squared. That is the limit as delta x approaches 0. That will be x plus delta x minus x squared minus 2x delta x minus delta x squared. And now I'll notice that there will be few cancellations. X and negative x cancel out, x squared and negative x squared cancel out. And if you notice, all the remaining term, there's a delta x involved, so you factor. And those cancel out. And once you cancel those out, you would try the shortcut again. If you let delta x equal 0, you're left with 1 minus 2x. So the slope of the tangent in this case, or the derivative, or the velocity, is 1 minus 2x. You give me an x value, I'll tell you what that number is. 2 more examples, so that's going to match your homework. Here, I want to figure out what the derivative is. In this case, that's the limit as delta x approaches 0 of g of x plus delta x minus g of x all over delta x. That is the limit as delta x approaches 0. So the denominator is the same. This piece is right there. And what is g of x plus delta x? Wherever you see an x, you replace it by x plus delta x. So those are the 4 types of problems that you come across all throughout. This wasn't intended. So that is the limit as delta x approaches 0. And again, if you let delta x equals 0, notice this will be 2 over x squared minus 2 over x squared. And you'll get the 0 over 0 until you cancel that delta x out. This is a complex fraction. The quickest way to simplify a complex fraction is to find the LCD for the top and the bottom combined, and that will be x plus delta x squared times x squared. And if all the pieces have the same denominator, you could write this as a single fraction. That's the shortcut. So if I can make this over x squared into x plus delta x, what is this missing? X plus delta x squared. And the denominator, isn't that missing the whole thing? So anytime you have a complex fraction, and we're going to see a lot of those, if you can make all the denominators the same, you can ignore them because when you multiply by the reciprocal, they're going to cancel out. So instead of a complex fraction, you're going to be left with 2x squared minus 2 into x plus delta x squared, and the denominator will be delta x squared into x plus delta x squared. Now all what you have to do is clean up the top a bit and you're in a very good shape. And the way that works, foil, yes, that's x squared plus 2x delta x plus delta x squared, divide, and the denominator you don't have to do anything because you already know what needs to be done. You need to get rid of this delta x. That's always the case. And if I distribute the 2n, negative 2x squared minus 4x delta x minus, that's a plus, 2 delta x squared. And it's no big secret that things cancel out every time. It was proven that that's going to happen. So those two cancel out. Do you notice both of those have a delta x in them? So if I factor a delta x out, I'll have a negative 4x minus 2 and you know what? Limit as delta x approaches 0, those cancel out. Negative 4x minus 2 over x squared delta x plus delta x squared. Oops, I thought that cancelled out. So that would be x squared into x plus delta x squared. Now, if you let delta x equal, did I miss something? Oh yeah. When I factored, that should have had a delta x left, right? Yeah, this is, yep. When I let delta x equal 0, that will be 0, that will be 0. You're left with negative 4x over x squared, and wouldn't that be x squared? And there it is. And that's the slope of the tangent. Now with a radical, we already dealt with a radical. Oops. If I want to find the derivative, that's the limit as delta x approaches 0 of h of x plus delta x minus h of x whole over delta x. That is the limit as delta x approaches 0. Now again, wherever you see an x, so there's the radical, x plus delta x minus 2 minus h of x is simply what you see. And here you'll notice you're stuck. If you let x equal 0, square root of x minus 2 minus the square root of x minus 2 is 0 over 0. So the only way to deal with this is to multiply by the conjugate. And the conjugate is exactly what you see. Okay, I'm going to modify this a bit. Okay, I gave myself some space. I pretty much extended that all the way down instead of moving to the right. So here it is. You multiply by the conjugate. The conjugate is the same exact radical that you see. So identical to what you see. Just make sure that they have opposite signs in between to guarantee that you're going to get. So if this is minus, that's a plus. To guarantee that the top will be, notice the denominator we don't worry about because we just want to get rid of that original delta x. As for the top, by multiplying by the conjugate, we're going to get the first squared, so that radical cancels out. Minus, and the that squared, that radical cancels out. So anytime you see a radical, the way out is conjugates. And here you'll notice those cancel out and those cancel out. And once I cancel that, I let delta x approaches 0, and I'm left with 1 over the square root of x plus 0 minus 2 is x minus 2, and what would that be? And there it is. And here, just to save space, okay, the rest is cosmetic work, I'll take care of it. And that's pretty much it. Go for the rest.